Hey sharks! Just like scientific notation can be used to write very large numbers, we can use scientific notation to write very small numbers. So remember when we did negative exponents? Negative exponents give you a very small value in between 0 and 1. We were using negative exponents written in a fraction form. But now you're going to see those very small values written in a decimal form. So keep in mind that very small numbers still require negative exponents, but now we're just going to see the number in decimal form. So here we have the number 0.00789. And in order to write this number in scientific notation, we need to move the decimal in order for it to become a single-digit whole number in between the numbers 1 and 9. So we're going to move the decimal places to the right. And for going from 0.00789, we have to move the decimal place 1, 2, 3 times, so it is between 7 and 8, and it becomes that single-digit whole number, 7.89. So be sure to count how many place values you move the decimal. That is going to be our exponent. Now let's rewrite the single-digit whole number, including the numbers after the decimal, but any zeros in the beginning can be dropped. So remember when we were doing large exponents, any place value zeros at the end could be dropped off. But now because we have a very small number, those zeros are in the beginning of the number. And again, they're just place value holders, so they can be dropped off. So let's count how many places we had to move the decimal to determine the exponent for 10. Going from 0.00789, we had to move the decimal place 1, 2, 3 times to the right. So that very small number became 7.89, and that small number becomes a negative exponent 3. So let's rewrite the standard number into scientific notation with that single-digit whole number, 7.89 times 10 to the power of negative 3. 7.89 times 10 to the power of negative 3. So that negative 3 tells me that it once was a very small number, and now we are using this in scientific notation to have the same expression, 7.89 times 10 to the power of 3. So let's try these. If I had the number 0.2467, I know I need to write a single-digit whole number. So that number is going to now become 2 point something, 2.467 times 10. And I'm moving the decimal. I have to move the decimal one place to the right. When I move it to the right, my exponent becomes negative, and I moved it one place, so I've got negative 1. So now my new expression is 2.467 times 10 to the negative 1, and negative 1 tells me that it once was a very small value. Here I have 0.0053192. I need a whole number in between 1 and 9, so I'm going to have 5.31092. Remember, all of those numbers are still important. They have they have value in those place digits. So I have to continue using all of these numbers, unless the question tells me to round. So we have 5.31092 times 10 to a certain power. Because my original number was very small, I know my exponent's going to be negative, and because I had to move it to the left, let's count. We're going from 0.0053, we had to go 1, 2, 3 spots to the right, so I now have an exponent of negative 3. Whoa, look at all of these zeros. Well, my whole number is simply going to be 8. 8 times 10 to a certain power. It was a very small number, so I know I'm going to have a negative power. And let's count how many times we have to move the decimal. 1, 2, 3, 4, 5, 6, 7 times in order to create a scientific notation. 8 times 10 to the power of negative 7. Negative 7 tells me it once was a very small number, but written in scientific notation, we have that single digit between 1 and 9. 8 times 10 to the power of negative 7. So we can also write the standard form from scientific notation. So remember that when we have scientific notation, the first number is always a single digit number in between 1 and 9 times 10 to a certain exponent. Here, my whole number is 5, and the decimal is at the end of 5. The exponent tells me how many times I have to move the decimal, and the negative exponent tells me it's going to be a very small number. So we want to move the decimal backwards to the left. You want to move the decimal back 7 places to the left because my exponent is a negative 7. So if the decimal was once behind 5, we have to move it 1, 2, 3, 4, 5, 6, 7 times. And it now becomes 0.00000005. Woo! That's a very small number. The decimal moves back 7 places, and we need to fill in those place values with any zeros. So let's try these. 7 times 10 to the power of negative 5. So I'm going to have 7, but I know I'm going to have to move my decimal place 5 times to the left. So 7, 1 decimal place, 2 decimal place. Why is this doing that? Hold on. Sorry. Alright, 7, and I have to move that decimal 5 times to the left. So 1 decimal place, 2 decimal place, 3 decimal place, 4 decimal place, 5 decimal place, and now I have my decimal, 0.00007, another very small number. Now I have 3.75 times 10 to the negative 2. Well, I am still going to need those digits 375, but I'm moving my decimal place 2 places to the left, a very small number. So the decimal starts between 3 and 7, and I move it to the left 1, 2 times. Now I have 0.0375, another small number. And last, we have 4.78 times 10 to the negative 6 power. So I have 4.7 are my important numbers. The decimal was once between 4 and 7, but I have to move it 6 times to the left. Back it up, small numbers. So here we go. 1 movement, 2, 3, 4, 5, 6. And here is my new decimal. We have 0.0000478. Woo! Small numbers. I hope that makes sense. Thanks. Bye.